Hi, this is Jürgen from IEC Systems, and today I want to talk about Eclipse NeoSCADA and how to configure IEC 6875104 devices, how to get a signal out of it, and configure that signal into a local SCADA master and a global master. And for that, I'm going to use Eclipse NeoSCADA 0.3 plus openSCADA 1.5. The first thing which we're going to do is to install the IDE with all the necessary components. For that, we're going to download the Eclipse installer from the Eclipse website. And we just run the installer using the advanced mode. We would have to choose, in this case, Eclipse Neon as a base installation, because the 0.3 version is based on Luna or Neon, and only the next version 0.5 will be able to run on Oxygen. So we just choose a directory where we install it, and in this case I'm going to use the same directory with a WS subdirectory to use as the workspace. So we now have started the IDE and we're going to install the additional components. For that, I'm usually using some Eclipse Mirror, because if we download it from the Eclipse infrastructure itself, it will take ages because the bandwidth is limited for third parties. At some point it's finished though, so we have to restart the IDE, and the next components where the actual IEC components are located are the openSCADA 1.5 editions. These live in a package drone channel on the drone.packagedrone.org. So we install it from there. Accept the license and the certificate. The last piece of software we're going to install is actually part of the Eclipse repositories themselves, and this is the Equinox target components. It's not strictly necessary to install them if you're just doing the configuration, but if you want to run a SCADA instance from within the IDE, this is necessary. Now that we have all necessary components installed, we want to create a project for that. For that we choose New Project, Other, and Eclipse NeoSCADA Configuration Project. We give that an arbitrary name, in this case IEC 104 Sandbox. And to test if all our installation stuff has actually worked, we just run the productive recipe. That worked in our case. So we have now two different models. One is the infrastructure model and one is the component model. This contains all the logical structure of our tags. We delete all the stuff we don't need and basically start from scratch. So the first thing which we're going to add is the definition of our IEC device. So we define what IP address it has, what we give it some name under which it will appear in the driver at a later point in time. So we call it IC 104 device in this case. And this is also the place where you would define what specific settings the IC device would have regarding protocol, timeouts, whatever settings. We also need to define additionally some server where we want to install the driver. For that, we create a system node. So basically, on a system node, we define every piece of software which we're going to install, where we're going to deploy our SCADA stuff. In this case, we give it also some name. Everything has to have a name. And we create the IC driver. This gets also some name. And in this case, it gets the instance number 15, which will translate to a specific port number later. And we also added our IC device. Now we can run the productive recipe again, and we will see that there's some configuration stuff put into the output directory, and we can actually take the created profile there and just start the driver and see that it's running. We also need to download the Eclipse NeoSCADA admin client so that we can have a look what's happening in the drivers. So I just pretend to have downloaded it right now and start it. Okay, so we have no connections defined now, so we add a new connection, in this case to with the port 2115. So this is where the instance number comes into place, because this 15 is basically the suffix to the standard 21 port all the NeoSCADA drivers and instances will get. So we connect to the server with admin and admin12 as name and password. And as we can see here, the driver is running. We can see some state, but it's not connected right now. So we take the simulator, enable it, and now it's connected. So we just send some signal, and now if we click that open, we can see there is some signal with some number on it. So this basically works. So this you could already use to access your IC devices if you'd like to. If you want to deploy it, we also need some deployment mechanism. There's some support for Debian and also RPM deployments. For that, we add the deployment mechanism. Additionally, we need to define some user. For that, there's a model file which is called deployment information, and we add it here. Okay, information. And here we can add our maintainer, the author. So in this case, it will be me and my email address and yeah, my name. Okay, this file has to be referenced in the other model. Okay, done that. And now we can select the just added maintainer. Okay, additionally, we need to add a change entry with basically some information. We need some longer string for the description because there's some restriction that I think it needs to be at least 10 characters or something like that. Okay, so this works, and if we run the recipe again, we can see in the output folder that we now have a Debian file, which we can deploy to some Debian-based Linux. Let me show you how to wire that up in a local or edge master and the global master. And for that we use just the same configuration as a starting point. So what I did now is added a master server. In this case, this will be our so-called local master. And we have to tell the master to which driver it should have a connection. And additionally, our global server, in this case, this will be localhost as well. So we will have to choose a different port. Usually it will be the same port, but on a different server. So that shouldn't be a problem. And of course, we had a master server with instance number 2. So this will translate in port number 2102. And we call it global master. And on that global master, we define the local master as an import. Okay, give it some name. And we can test the configuration already. Okay, as we can see now, additionally we see the global master. Of course, it doesn't have a deployment definition right now. We can just copy the one we already have. And if you run the configuration now, the recipe, I mean, there, we have a Debian deployment for that as well. Just to rename it a bit to give you a slightly better idea what the purpose of those servers are. And now we will have a look at the component model. As I said already, this defines the logical structure of our tags. So in this case, we have our country, so it's DE. We define some, let's say, region. let's call it region. And let's say a device which we want to access is, I don't know, one plant. So just let's call it plant 1. And we want to define that as an external way because we get it from somewhere else. So this specific component runs on our local SCADA, our edge SCADA server. Yeah, let's define as a float component. We want to get it from the driver, and we have to define the name, how it appears within the driver itself. So it's basically driver name dot data dot the signal name. Let's call it my tag, and we can have a look how the whole thing looks like. So basically the actual tag name will be DE region plant 1 my tag dot v. Okay, now we can run the recipe again. In this case, we also want to run the global master. And if we have a look at the global master, we have to add the connection first, of course. In this case, the global master has the instance ID 2, so it's 2102. Again, admin12, and as we can see, nothing is there. So we're missing the tag. So how does the tag actually ends up on the global master? One interesting thing which we can already see is the connection to the local master. So the server already has, the global master already has a connection to the local master, where the connection is closed right now because we haven't started the local master, which we're doing right now. So if we go back to the Eclipse SCADA admin client, we can see that the connection is now bound. So we added also the connection for the local master, which we can connect to, of course, because we just started the server. And there we have my tag. It doesn't have a value right now because we have not started the IEC driver, and it's still missing on the global master. So we add the globalized component, and we want to add our tag to the globalized component. So the name for the globalization component is just arbitrary, it doesn't really matter. We have to define which is the source master for it. So this refers basically to the import we defined. And now we can also select the one of the available components, in this case my tag. If we run the recipe right now, and start the service again, we can also just save the password within the URL, which makes it a bit easier because we don't have to enter the password again and again. And when we have a look now, we will see that we have in both the local master server, and the global master, the tag my tag available. Okay, just to show you a bit better that looks like. So on the bottom we have the global master, and in the middle this will be the local master. So in both cases it looks pretty identical. Some more attributes on the global master because the summary of the error and alarm values is a bit more involved there, and it still doesn't have a value, of course, because we haven't started the IEC driver. So we do that now. Just to show you, the local master has also a connection to the IEC driver, which we can have a look at to get an idea if the connection is there or not. So it's closed. If we start the driver right now, the connection should be bound. Yes, it is. So of course the driver itself doesn't have a connection to our device. You see, state is sleeping, and I think we still have some naming issue, which we will fix in a minute. Okay, so now we see the IEC driver has connected to our simulator, and as I said, we still don't see any value on my tag because there's some naming issue. Okay, so everything we have here is some Boolean values, I think. So we simulate a float value. That's the wrong one. I'm not usually using this software, so excuse my fumbling around with it. So just set another value. As you can see on the top, it is now the same value, 3.14 whatever. And yeah, so okay, the two things, we haven't sent the signal 00001 yet. Okay, we did it now. And just send something different too. Yeah, but there's also the issue that the name for the tag from the driver is not correct, so we have to fix that. So yeah, it's actually called IEC 104 device and not just IEC 104. Okay, so if you change it here to IEC 104 device, then it should actually work. Okay, again, run everything. Yes, of course, change the configuration, the connection name, so we have to drag it over again. It's now connected again, so we just have to send our signal again, which we didn't before, and now we have it here, so it's it should be 2.0. And now when we start the local master and the global master, okay, authentication has some problems. Okay, just restart the servers again, and then we should be fine. Send the value again, so we have 2.0 again. Run both masters. And now we can see that on the global master we have the correct value 2.0. And on the global master we should have the same value. Now we can see same value with the same timestamp. Everything looks as it should. So if we change it, we should see instantly that the value changes on all servers. Okay, so we have 0 on it. $42, and it's on each and every server. What I also want to show you quickly is how the manual values work. So we set a specific manual value, 13 in our case. This actually gets set on the local master. So somebody who would connect to the local master specifically would see that manual value as well. So it basically lives on the local master. So we can just set the manual value on the local master, and of course see that we have a manual value on the global master as well. Okay, so that's basically it. Thank you for your attention, and don't hesitate to send me an email if you have any questions.